Yeah. Audible, audible.
Okay, I am Igor Nesteruk, and thank you for giving me this opportunity to participate in this webinar and for your introduction. And I want, do you see the screen? I want to show you some results which are published just now in the Journal of Innovation, Biosystems and Bioengineering. The organizers has the link to this article. It is already published and it is available in internet. The topic, you know, simulation and prediction of COVID pandemic with the use of SIR model. Do you hear me? Is okay?
Yeah.
And do you see the screen?
No, still not. Show your screen.
Just a moment. Please open my file then.
So double click on your
Sir,
screen.
sir, please click the button, the share screen. Yes.
Now you see.
Yes.
Yeah,
Yes.
exactly.
Yes.
Okay, and I don't go to mathematical details, but I want to say first some headlines. You know that detailed scientific analysis of this phenomena will yet to come, and it takes a lot of time to understand. But now people are already interested. For example, what is the duration? How can be the duration? What is the expected number of victims of infected people, and also where and when the epidemic started. It was a big discussion in the internet, a lot of fake news about the origin and place of origin of the epidemic. And sometimes mathematics and statistics can help in this to understand where is the beginning, for example, and when it happens. And I have done a lot of investigation with the use of SIR model. This model is known. It is not new. It is more than 100 years old. The thing I have proposed is the methods of identification of the characteristics of this model, because this model has some unknown parameters. These parameters are has to be evaluated with the use of the statistic about the number of cases we have and how this number of cases developed versus time. Therefore, let's go to the details. As I have already told that I have done some simulation first for China, then for Republic of Korea, 3 times for Italy, 3 times for Austria, Spain, Germany, France, Republic of Moldova, Ukraine, and Kiev. Because now we have, before we have total lockdown, it was possible also to use this model and to simulate for not only for entire country, but also for regions of the country. And I have done some simulation, for example, for our capital here, and some predictions as well. And in this study, I have used the data, official data, as usual, official data of World Health Organization, the WHO, to simulate and predict the development of epidemic in South Korea, Germany, United Kingdom, USA, and also some global dynamics. It was data from 9th till 29 April was used for calculation, you can see this, and other data, other days after was used to check how to check the accuracy of calculations. You can, these data are absolutely official, they are available in internet, and you can check any figure with the use of WHO daily situation reports. They are also available in internet, and the link is in the article. You can do it. What we do with this data? We use this so-known CIR model. There are some 3 differential equations. It's a known model. There are 4 parameters, which are these parameters. There are this alpha rho. Then we have also n, the number of involved people. And you can, it is written what does these parameters, what is the medical and economical sense of these parameters. And it is also very important to know about this parameter n, where is the sum of susceptible, infected, and removed people. And usually people, in some literature, people say that it is the number of people in the population. For example, how many people live in India, but it is not true. It is only people who are not protected, who are, for example, if we have quarantine, their n is much less than total number. For example, the population in India is more than 1 billion, but involved people cannot be so great if you have enough quarantine measures. And what about this model? That is old model, more than 100 years old. I have applied this model and have obtained some solution, analytical solution. It is written here, it was obtained 3 years before. And this analytical solution can be used for parameter identification procedure. It is also, maybe I don't have time to go into details, it is not so interesting, but there is some statistical background how to identify the values of these parameters in some optimal way, to find the optimal values of the parameter. It is written in this part, and now we can go to results. We have used one period of time, April 29, it is 21 days, to identify these parameters. And the results are given in this table. There is predictions for South Korea, prediction 2, because before I have done another one, as well Germany, 2 predictions for Germany. And for example, this model is able to predict, for example, the final size, how many infected people we can expect for every country, some saturation level. For example, for Korea, the prediction was around 11,000, and there is a value for value for yesterday, the number was around 12 in Korea, and they are close to saturation. The number of cases in Korea, in South Korea, does not increase very rapid now, very slow now. The same, for example, for Germany, saturation level was this, and the number is this one. It is around less than 10% less. Therefore, this method can be useful and can give some reliable predictions. But in the case when we have more or less good information about the number of cases, usually at the beginning of the epidemic, the number of cases is not reliable. People and authorities and medical staff don't know how many people are ill, and they cannot give us the correct number. For example, for USA, the prediction was only around 1.5 million, but we know that now this value exceeds 2 million. The same for the world dynamic. And for these cases, we need to re-estimate later to know, to have better results. And now there is some table with my previous estimations and predictions. How many minutes I have? Yet? No? More? Yes, and I want to show some graphs. There is the development of pandemic in different countries, and also the world dynamic, this brown line. There is the number of cases, this solid line, and dashed line is the number of people who are infected and not isolated, who spread the infection for world. But it is only, for world, it is only preliminary estimation. It must be recalculated later with the use of more exact data. Also, there is for Italy, for USA, and we can see, for example, this green line, it is the theoretical estimation, and this green triangles is the cases which were confirmed in Italy. And you can see that we have very long hidden period. Around 3 months, people medicals in Italy have not seen the cases, and it was epidemic. It was, and for every country we have such hidden periods, and also for world dynamic. For example, according to this estimation, the epidemic started before September, before the end of September, this point, but first cases which are officially reported in China are this one in Wuhan. And you can see that it is a large hidden period. And for India, for sure, we have the same. And there is the development after 1st of March. The number of cases come closer to the theoretical predictions. These values used for prediction are shown by circles here. And we can see that it is rather good correspondence of new cases, these stars, with the theoretical curves. For example, I have estimated 3 times for Italy, and the last one is this value, and the value, the real value for yesterday, it is only less than 10% higher. It means that simulation is rather, the accuracy is rather good, and also we can do it, for example, for India as well. If we have such set of data, it is possible also to calculate for India and make some predictions about the final size, how many people will be ill, and how many and when we can expect the finish of the epidemic in India. And I have done also some things about Ukraine. For example, it was a problem with testing, and due to this problem, we have data which were not complete. And with this not complete data, we have a very optimistic prediction, this dashed line. But after the testing was improved, we have much more pessimistic prediction, and unfortunately, the real number of cases is still greater. You can see these stars deviates from the line. It's for Ukraine. Similar investigation I have done for our capital Kyiv. You can see here is a little bit better, but unfortunately, last points also deviates from this curve. And some, for example, some we can also estimate with the use of this SIR model. We can estimate the danger. For example, this curve, this green curve, show how many people are ill, spread the infection, but are not isolated. They still spread the infection. And we can see in every day, we can see how many people are in Kyiv, for example. We can calculate the probability to meet such person. For Kyiv, it was not very high. But if you have more contacts, for example, M, this probability to meet at least one infected person can be estimated by this formula, and it means that if you work, for example, in a metro station, you meet many people, your probability to meet an infected person is rather high, can be rather high, and you can get infection if you are not protected. Therefore, the protection is very important, and also quarantine is very important to decrease this number of meetings. If people are staying at home, they don't meet any people, and the probability of infection is low for this. And a very important question, can the pandemic be avoided? Was it possible to avoid such tragical consequences? This question may be answered positive. The situation with Hong Kong, you know that it is actually a part of China, specific but part of China, and they have started to isolate themselves last day of the last year, December 31, when they have obtained some information from the internet, not from official channels, from internet, they immediately started to isolate themselves, and they have the number of cases in this area. It is not very. It is around. It's written around 1,000. There is on May 9th of May, and for example in Kiev, in the smaller city with small population, it was already 1.7 times higher. Therefore, information is also very important. If you have a good information, as if you start to isolate and to isolate yourself and to isolate the infected persons, you can have good results. Therefore, to conclude, I have to say that this model is suitable. It can give a possibility for making some reliable estimations for epidemic dynamics. And this information obtained with the use of this PIR model may be useful to regulate activities and to predict the medical and economical sequences of pandemic. And there are some figures that pandemic started not later than at the end of September, maybe even before the end of September. The estimation will show us this. But unfortunately, it could continue later than mid of March. We have a long time and maybe also later. And the number of infected people could exceed 5 million, and we already see that we have more than 5 in the world. We have more than 5 million of cases. Thank you for and I want to thank people who help me with data. There are the names you can see. There are my friends from Ukraine and Austria as well. And thank you for your attention. I'm ready for questions and discussion.
Hello, sir. Am I audible to you?
Yes, I hear you.
Thank you very much, sir, for your precious lecture and your valuable data. Some questions are there. I have put some questions privately to you. And if it's not possible, I can ask you some questions directly. Can I ask you, sir?
Yeah.
Yes. One question is there from the participant that what could be the future of our social life if the COVID-19 persists?
People are writing the questions.
Yes.
Okay.
The question is
it's better to write because
yes, sir. I'll write it.
I understand written English. I understand much better than oral.
Some questions are there in your personal chat box, sir. Kindly check the personal chat box.
Chat box, okay.
Chat.
Oh, I see. No. Oh. I don't see any text. I see the people.
There will be a text, sir, in the chat box. You can see there what is the future of social life if COVID-19 persists. Can you see?
I see chat box, but maybe it is chat box. I don't know what I see.
Kindly click the chat box, please.
Yeah, I can see chat box, but I see only names. Now.
There is a question, what is the future of?
Okay. Do you see questions for me?
Yes, sir, I can see the questions. I can read for you also. Can I read for you?
Maybe let us write, but yeah, let us try to read.
There is a question in the chat box. What is the future of social life if COVID-19 persists?
Oh, I'm not a guru. I uh, cannot say, but in any case, we have to have uh, to change our habits. We have uh, to make more distance with people. Unfortunately, we don't need to kiss, for example, during the meetings, or to to shake hands, maybe long time, to use mask in populated areas, crowded areas. It is especially important for India, and avoid crowded places as well, because it is dangerous, especially for uh, older people who has to be very careful in this time.
So another question is there. Will there, when there will be peak of COVID-19 in India?
The peak, the maximum point, you need.
Yes, in India.
Uh, Unfortunately, I have not worked with Indian data. I am very busy with Ukrainian data, European, but in principle, you can use the all the equations in are published, and you can use this method to calculate for India. If I have more time, I can do it also for India, but unfortunately now I don't have any results for India. But I think uh, no, it's better not to say, because I don't know the your figures and have not calculated. For example, for Ukraine, we still have cases all the summer, and I'm afraid that we can go, the epidemic goes to the winter time, and it is very dangerous, because in winter time people are more weak, and also there is a lot of season disease similar to COVID, and it is very dangerous. We can have the new wave of the epidemic then.
Sir, thank you very much, sir. There is another question that will the number of infection will increase in future, or will they will come to a peak and will go down?
Uh, any epidemic come to some uh, saturation level. The number of cases, the accumulated number of cases increases permanent and come to some saturation level. I can show. Can I switch to the screen, to my screen? No.
Yes, of course, you can share your screen, sir.
Where? How?
You just have to click the share screen.
Now you see the lecture.
Not yet, sir. Try again, please. Share the screen, double click it.
Yeah. Do you see? Do you see my screen?
No, sir, not yet.
Not yet. Okay. What?
Try please, just click on the share screen.
Once more. Now.
No, sir, not
But
yet.
you have a copy. You have a copy of
Yes, we
my
have the
file.
copy. Yes, sir.
You can open figure 2,
Yes, sir.
and you see that there is some saturation level for every country. For world, we have some saturation level, but unfortunately, it will be. We have to wait a long time, rather long time, to have this saturation level.
Thank you very much, sir, for your valuable information and interaction. I think
More questions?
I think the questions are done. I think the relevant questions are done. Now we'll move to the vote of thanks. It's my immense pleasure, sir, that you came here, you gave your precious time to us, and you interacted with us. At this simultaneously, all our participants are feeling pleasure to meet you and hear you. And
Thank you very much. Thank you very much. It was pleasure.
Yes, sir. And we feel that in future also we'll have some common talks on this.
Okay, if you have more questions, you can the email my email address in the text, and you can use it to ask questions after the seminar webinar.
Thank you very much.
Thank
sir.
you. Thank you for your attention.
Thank you very much, sir.